Hello, good day, and this is me once again, your instructor for the subject Foundation Engineering. And today we are going to continue the Terzaghi'S bearing capacity theory. And actually, we are going to solve one sample problem for this day. And proceeding with this sample problem, so we have now this square foundation, measuring B by B is subjected to an allowable gross load of 2000 kN with a factor of safety Fs of 2.5. Assume that the depth of the foundation, denoted by this d sub f, is 2 meters and that general shear failure occurs in the soil. The soil supporting the foundation has a friction angle of phi prime equal now to 25 degrees and your C prime is equal now to 20 kilopascal. The unit weight of the soil is 16.5 kilonewton per cubic meter. Okay, so as our solution for this, since based on this problem, the dimension of the foundation is B by B, meaning it is a square foundation, and given is the allowable gross load of 2000 kilonewton. So this 2000 kilonewton is our Q allowable, okay, and our Fs is 2.5. Okay, so proceeding with this, from the allowable gross load formula, we have here this Q allowable equal now to this capital Q over the area of the square foundation B squared. Okay, so this formula we can actually rewrite this one into this form. Okay, Q allowable is just equal now to this load capital Q allowable equal now to B squared. Okay, we use this formula in our previous lecture video regarding this Terzaghi bearing capacity theory, but in this problem we are going to assign this capital Q equal now to this Q allowable, and then our capital Q is just equal now to this capital Q subscript allowable equal now to 2000 kilonewton as given in the problem. Okay, so I think you can better understand and simply memorize this formula if you consider this small q allowable is equal now to capital Q allowable over B squared than using this formula from our previous lecture video. Since it involves allowable value, so probably your small q is just a function of this capital Q allowable also, okay, over B squared. Okay, so I advise if possible to adopt this formula for an easy recall of this small q allowable is just a function of your capital Q allowable over the unit area of the foundation. Okay, so proceeding, so we have also this small q allowable is just equal now to this small q u over the factor of safety, and I hope that you can still remember this formula in our previous lecture video, and we calculate this small q allowable as a function of this q ultimate denoted by this small q sub u over the factor of safety. Okay, so by this we can say that the factor of safety is just equal now to this small q ultimate over this small q allowable. Okay, so from this formula we can actually determine the factor of safety, which is the ratio of your q ultimate over the q allowable. Okay, and also we can rewrite this one as a function also of your load, no, capital Q. Okay, since this is an ultimate small q over the allowable small q, which is referring now to the bearing capacity of the soil. So we can also express this factor of safety as a function of our capital load q, which is also considering the ultimate load q over the allowable load q. And we can have now this formula for this factor of safety as a function of your ultimate load over the allowable load rather, with this capital Q. Okay, Q capital QU over the capital Q allowable. Okay, so I think you better if you're comfortable of using this formula, so much the better, no, if you are going to use this one. Okay, so by this formula we can therefore say that given the fs of this 2.5, and then we have now this q allowable, which is also equal now to our q here in this formula, so we can actually determine our q sub u. Okay, so calculating this one, so we have here 2.5 equal now to capital Q ultimate over the capital Q allowable, and which is equal now to this ultimate load Q over this allowable value of your load Q of 2000. So we can therefore say that our capital QU, or the ultimate load, is equal now to 5000 kilonewton. Okay, so proceeding now with our calculation, we have now this small q, this q allowable over this load q over the b squared. So we have now this value, okay, from this formula. So we can therefore say that our q ultimate is just also equal now to this load ultimate load capital Q over this b squared. Okay, so we can also rewrite this one, no, using this ultimate load and this ultimate bearing capacity of the soil. Okay, so by this we can say that our ultimate load Q is equal now to 5000 kilonewton, and we have now this area of the foundation, and it is denoted by this b squared. So we can actually express, no, we can actually express this value in terms of the b squared. Okay, so we can therefore write this one, given this ultimate load of 5000 over the b squared, equal now to the ultimate bearing capacity small q sub u. Okay, so in terms of b squared, so we may say that the product of your small qu times b squared is equal now to 5000 kilonewton. Okay, so we have now this relationship, no, of your ultimate bearing capacity of the soil, denoted by this small q sub u, times b squared is equal now to 5000. Okay, so if you can remember the formula of getting this ultimate bearing capacity of the soil, denoted by this small q sub u, since it is a square foundation, so we have now this formula. Okay, This bearing, ultimate bearing capacity of the soil denoted by this small q sub u is equal now to 1.3 C prime NC plus this small q times NQ plus 0.4 unit weight times B times this bearing capacity factor N subscript unit weight. Okay, so this is the formula for calculating the small q sub u in terms of this square foundation. So based on the given problem, we have now these given parameters. Our friction angle P prime is 25 degrees. Our C prime is equal now to 20 kilopascal, and our unit weight of the soil is 16.5 kilonewton per cubic meter, and our depth of the footing from the soil surface is 2 meters. Okay, so we need to determine this bearing capacity factors NC, NQ, and this N unit weight. Okay, we need to determine this one first, since the C prime is given and this small q is just simply equal now to the unit weight of the soil times the depth of the foundation from the soil surface. So we can say that in terms of this formula, we can get the value of our ultimate bearing capacity Q sub u in terms also of this dimension of your square foundation B. Okay, so first we need to calculate the N sub C. So again, you can recall from our previous lecture video, you can use this formula in calculating the N sub C equal now to cotangent of your friction angle P prime times this NQ minus 1. And we need to determine first this NQ to get the NC. So we have now this NQ formula equal to this e raised to the power of these 2 times 0.75 phi minus p prime over 2 times tangent phi prime over this 2 cosine squared of this 45 degrees plus 1 half of your p prime. So again, the angle is in radians. So we need to express this p prime, this friction angle in radians, and also convert this 45 degrees into a unit of radian. So proceeding with this one, so we have now this value of our 25 degrees in terms of radians, so it is just equivalent to 0.436, and then our 45 degrees here converted to radian, so it is just equal now to 0.785 radian. Okay, so calculating this one, so we can actually get the value of our NQ equal now to 12.71. Okay, so we can therefore say that our NC is just equal now to this NQ minus 1 times this cotangent of our friction angle. Okay, so using this formula, so we can have now this. Take note again that this friction angle P prime is in radian, so we can get the value of our NC equal now to 25.13. And finally, calculating our last bearing capacity parameter N sub unit weight is equal now to this formula using the Hansen, 1.5 times NQ minus 1 times tangent P prime. Okay, again, using this P prime in radian unit, so we can have now this value of our N subscript unit weight equal now to 8.18. So now we have this value of our bearing capacity factors, NC, NQ, and A unit weight. We have this unit weight of the soil. The only thing that remain unknown here is the B, which is a function of your QU. But here we have now this QU in terms of B, so we can actually solve the value of our B here later. So proceeding, Using this formula, so we can substitute the calculated value of our NC in NQ and this N unit weight. So we have now this 1.3 times the C prime of 20 kilopascal times NC of 25.13 plus this small q is just simply the unit weight of the soil times the DF, which is 2 meters, times this NQ of 12.71 plus 0.4 of this unit weight of the soil, which is 16.5 kilonewton per cubic meter, times B, which is unknown, and this 8.18. So we can actually get the value of your small q sub u in terms of B. No, we have now this 1072.81 plus 53.988 B, and substituting this q sub u into this q sub u B squared equals to 5,000. So we can have now this substitution here. Okay. So if you are going to solve for the value of your B, which is the only unknown variable here, so you can also use the trial and error here, and using your scientific calculator, so we can have now this B equal now to 2.06 meters, or we can say that it is just equivalent to 2.1 meters. Okay, so this would be now the dimension of our square foundation given those parameters of your C prime, the DF, and we have also now this 2000 kilonewton, and this would be it for this problem. Okay, so in our previous lecture video, actually the value of our B is given, but we need to determine the allowable load Q. But in this sample problem, we do the reverse. We are going to determine the value of your B of this square foundation given the load Q allowable. Okay, so I hope this lecture video will help you, and I hope that you have learned a lot for this problem. And again, for our next lecture video, I will give you a sample problem regarding this circular foundation, and also later on with regards also to this rectangular foundation. So we are done with two sample problems for this square foundation, and I hope we will see each other again on my next lecture video considering circular foundation and this rectangular foundation. Okay, so these are my references, and thank you for watching and listening this lecture video of mine, and hope to see you again soon in my next lecture video. So God bless everyone, and bye bye.